now that we have our member end forces for this frame, now we can go do our shear and moment diagrams. And that's what we'll do here in part 2. So remember, we've got all these little pieces, the columns, the joints, the beam segments up to the hinge, etc., all the way around the frame. And so we have to decide what our sign convention is for what's going to be the positive direction. So I've indicated with the little smiley face what the positive bending moment would be, and that tells us the direction also of what's going to happen with the shear. Because look at from A to B, if this is where the curvature is, and I'm standing over here looking that way, and 6.25 is going to go from 0 and follow the arrow, so we'll have a minus 6.25 for the shear, and no transverse load, so we have a uniform shear. It goes all the way up to, again, minus 6.25 up the top and straight across. Likewise, we would have the same thing over here on the column. There's our positive smiley face, so we'll go follow the direction here as though we were standing on this side, go follow the arrow, and that makes that a positive 6.25 top and bottom for those. Right, now in the shear diagram, we're not going to have continuity as we go around the corner, because the shear in the column becomes an axial force in the beam and vice versa, given that 90-degree angle. Right, so there we note that we've got a 20 at one end, we've got 20 at the other end. So this is sort of more conventional in what you're used to. We go up to positive 20, and then for every foot we'll drop by 1 kip, right? And we're going a total of 20 feet all the way across. So plus 20 minus 2 times 20 will give us a net of negative 20. So we have an anti-symmetric shear diagram, and of course we have that final shear here that goes up and closes us off to 0, just like we would want to see. So there's your shear diagram. Now your moment diagram is going to follow similarly, that we then will start at 0 moment at the far left end, not because it's a pin support, but rather it was a fixed support, but when we calculated the reaction it turns out to be 0. So now we've got a negative shear, so a negative slope, and minus 6.25 times 12, we already know is 75, and that gives us a net change then of negative 75 starting from 0. Again, that sign convention follows from where we put our little smiley face, and they got to be the same in both of these. Likewise, when you come over to the column, now we start at 0 because we have a pin support there. We have a going from, so to speak, left to right, bottom up, as we're standing over here looking at the smiley face. Then 6.25 plus, that is a positive 6.25, times our 12 is a positive 75, and so we go from 0 in a straight line fashion to positive 75. And then finally we end up needing to look at the horizontal beam and note there that we start off with a frowny face 75, right? So sort of on the same side as what the column was, and we are supposed to end up likewise with a frowny face 75 over here. We need to pass through 0 at 5 foot over, and we do already know that it does because we've worked on this before, but we know that we're going to have a big positive slope. It's going to pass through 0 there, pass through 0. Shear diagram is first order. This then is going to be second order, and it's going to be a nice, wonderful little parabola. Let's not freehand it. Let's instead get our French curve out. And we need, this is a little tricky for how I've got this set up just because of the, I chose a fairly small little diagram here, and I want to make that symmetric. You're wondering, how do I know it really works out that way? Well, here we go. We have a change in moment that's equal to this area in the shear diagram, and so that total change from the left to the midpoint, we know it's the midpoint because of the anti-symmetry of the shear diagram. So that total net change is 1/2 of 20 times 10, or a plus 100. Right, so we started off at minus 75 plus the 100, we come up to 25 there, and then we'll decrease again back down, and that'll take us to here. And again, when we check this moment, it will be 0 right at the hinge location, just like it's supposed to be. And so let's get our units in for both of these. There we go, and there's our shear and moment diagrams. Let me zoom into that for you so you can see any last final details.